My name is John Foltz. I'm Director of User Interfaces at Wolfram Research. I'm giving a talk today on realizing interactive documents, and I'm going a bit back to basics, talking about how you construct CDF, interactive documents generally. I'm going to be talking a little bit about some new features as well. Okay. So I was still trying to add stuff to my talk, even like 3 minutes ago, and for some reason I got 20 minutes off. So hopefully I left the talk notebook in good shape. Okay, so a little bit of an introduction here. The first half or so of my talk is going to be what I think of as bread and butter talk. I've seen some impressive things that some of you folks have done, and this will start at more of an introductory level, but I think also there are a fair people out there who have questions about how does some of this stuff get done, or they kind of feel like maybe they know, or they kind of copied something they saw, but they're not really for sure. So I decided to start with some basics, and for those of you for whom this feels a little elementary, stick with me. I'll try to give you something toward the end here. So, and I have no idea how long this talk is going to go. I have 2 codas. They are ejectable. I don't want to get in the middle of Roger's time. So, when I say realizing interactive documents, well, let's just start off with the basics. What is an interactive document? Well, it's a document that's it communicates information. And obviously, since you're wanting to communicate, then you're going to disseminate it to people. What does interactivity mean? Interactivity means, well, at least in the way that I was thinking about it, that it responds to stimulus. And so that means that I think that it encourages exploration. So let's start on the interactive side, but putting together documents is kind of old hat. We've been doing that for 30 years. Let's start on the interactive side, and then let's see how we bring these concepts together. Okay, so let's build some simple interactivity, and the concept that I want to go with here is that you may think big in terms of the final product that you want to make, but everything starts somewhere, and you can start very simple and iterate. And this is, the ideas and the techniques that I'm going to be discussing here. This is how we do things at Wolfram Research. We're not, we don't think fundamentally differently in terms of attacking some horribly complex thing. We start small and we iterate, and that's one of the beauties of Mathematica, is that you can really, you can experiment, you can add, you can tweak, and it's very amenable to that kind of workflow. So, I'm going to build an educational document, something that. And the example that I came up with was something that teaches a little bit about gray code. Now, gray code is a binary encoding mechanism that basically encourages, or that basically requires that whenever you move from one binary number to another, that only one digit flips at a time. And so there are some fairly simple rules for generating gray code. And I'm not starting off with interactivity at all. I'm just starting off with some code. So I have some code. You can see, oh, and by the way, I'm using a convention here just so you can follow along with me, that because we are iterating the code, you're going to see some of this code over and over again. Anytime I bring new code in, I highlighted it in blue. So you're going to see that for several more slides here. Okay, so I have a function that purportedly shows some gray code, and sure enough, that's what we have here. And I can, that's gray code involving, okay, I didn't think this through very well, that's 3 digits worth of gray code when I passed in 2, but there you go. I was up very late last night. And we can get more as we like. Stunning. So we've started off. No interactivity yet, but we're just building components a little bit at a time. Right now we have about 5 lines of code here. Okay, so let's build up from there. Now we have some interactivity. Well, this is easy. It's just to manipulate, and that number that we're doing, that gets passed into gray code. That's just to manipulate parameter. And this is just to make it look pretty. So here we go. And here, well, it's going to ruin the appearance, I think, of the resolution. Unfortunately, has flipped the slider to the left instead of the top. Well, that's unfortunate, but let's not fix it now. So you get the idea. We have something that can easily demonstrate what the pattern of gray code as you expand the number of digits. Okay? So now let's try to make it a little prettier. So what I've done here is, or actually a little more instructive, I should say. So one of the interesting points about if you're going to talk about gray code is that at any time you add a digit in front, that basically the digits to the right are mirrored. So I'm just throwing a line here in the middle that indicates we have 0, 1 mirrored to 1, 0. And similar, if I come out to a slightly larger view, we have the digits on the right here, which are all mirrored, flipped over this green line. So all I did was just to add that. And you see, we didn't have all of our ideas at once. We started simple. The code maybe now looks a little more intimidating than it did before, but we didn't start with intimidating code. This is very incremental. Okay, this reflection property, I wanted to emphasize it some. So I made myself a couple of functions here, which just basically show things above in red and things below in blue. And then here I'm mapping the function in. So now, still, here's our same manipulate. We've iterated again, and now we've emphasized this notion of the reflection by showing the different colors here. Well, I do want to be explicit about that, so this is just a little graphic, just to indicate that we do have a reflection here. There's nothing particularly challenging about this. It just the upside down thing was just a particular use of scale with the 2 arguments there to get it to flip the way that I wanted it. Aside from that, it's just 2 graphics that are in a column. It's going to line up directly with our grid. So let's take a look at how that plays in. So we had defined our graphic here as mirror. We're just going to put it in a row. So very simple. And now if I manipulate it, we can see hopefully something that is more illustrative of the concept. So can this live without a textual explanation? No, that's why we're creating an interactive document. It involves both text and experimentation. This is a good thing. But can we put this into a document? Now, this is So this is something that maybe is not a very well-known feature, but it should be a better-known feature. Now, eventually, I might want to obviously not just run shift-enter evaluations. I want to be able to deliver this in final form. So can I do that? Let's I don't want to work with my whole talk notebook here. So let me create a new notebook here with I just copied and pasted that manipulate. And now let's do a CDF preview. And what we're doing here is we're going to take this notebook and we're going to try to see what would happen if we dropped it into CDF Player. Would it work? What do you think? Let's find out. Okay. Wow. That didn't work at all. We've forgotten something. So one of the fundamental issues when you're working with deploying interactive documents is that you have to include the code. And when I say include the code, I don't mean putting the code in there so that somebody can run shift-enter and then be able to see the same stuff you saw, because that's a crummy experience. Nobody wants to do that. What you really want to be able to do is, these manipulates, these are, and other associated constructs like dynamics, they're live code execution environments. And you need to make sure that all the code that you're relying on is actually prepped and initialized in those environments. And we can see right now, we had a definition for gray code, we had a definition for colorize, we had a definition for mirror. So none of these things are in there. Well, that's a problem. And we could have waited and launched a separate copy of Player, or maybe quit and restarted Mathematica to try to find that out. But it's much easier to figure out this sort of problem inline. And so that's what the preview feature is for. Okay, so let's fix that problem. Now, I'm not going to go into lots of details about the various ways in which you can fix the problem. I'm just gonna go for the simple case here, which is save definition 0 true. This is a very nice option to manipulate, which basically says, well, look for anything that's that looks like user-defined code in here, and look for all the down values and just slurp them all in and include them with manipulate. Now, actually, when I write code, I tend to use specific initialization options so that I can better control exactly what gets included with manipulate. But this is easier to do, and pretty good chance of it working. Well, some other things that I want to do in the process as well. So I'm setting deployed true. Why am I doing that? Let's take a look at the one of the interesting properties of this is that you can do selections in here. Sometimes, select the graphic and resize it, and well, sometimes that might be a desirable feature. In this case, it's really just a way for the user to kind of mess things up that we don't want. So I'm setting deployed true, and then I'm putting the whole thing in a print. Why? It's not particularly required, but print statements have the nice feature, which I'm going to rely on momentarily, that they don't have cell labels, the in and out numbers attached to them. So that's, and anything can be, if it can be output, it can be printed, and that includes interfaces. So let's go ahead and do that. And now I have something that is, you see there's no out label here. And the manipulate still works. If I select inside of it, nope, I can't select inside of it at all. And now let's take that guy and copy it. Wow, what did that do? Okay, and paste it. And now let's do our same preview on this. And here we go. Here we have something that seems to be working fine. So it doesn't just seem to be working fine, it is working fine. Here we go. Okay, so now we've put together interactivity. You know, when you look at all the code together, it looks kind of intimidating. But we started simple, and we only really just tweaked and added a little bit every time. You've seen these blue code blocks here, and there hasn't been much going on new at each stage. Okay. So how do we turn it into a document? Some things that would be nice to turn into a document. Maybe I'm going to come back and do this again. Maybe I'm going to tweak it. Maybe I made a typo and I want to fix the typo later on. I don't want to throw away the code. So all that code that I just wrote, I want to preserve the code that generates interactivity. And I want to make it easy to make modifications. So the simplest way might be we could just hide it inside cell groups. And so here I have an example. I've written, okay, I didn't write it. I copied and pasted from Wikipedia. But I have some text here which explains a little bit about gray code. And then I also just created a little table here, nicely formatted table. And so, as most of you probably know, but in case anyone doesn't, you really should know, I can now double-click on the print cell here, the output cell, to reverse close a cell group. So the code is still there inside that cell group. And then the same thing here. So here we have, this is just all the same code that we saw before, nothing different. And we're going to evaluate that, and then we're going to reverse close there, and there we go. Now we have a document that we generated with code preserved, and it has interactive components. This is great. Although, well, really, the code is still sitting inside here. It would be nice if we didn't potentially expose that to to a user who's just clicking around. Maybe we want to for educational purposes, but let's say that we don't. Well, another possibility to deploying is we could build a new document, and we could write a program to do that. Don't worry, not scary. It's actually a lot easier than it sounds, and it has the nice advantages. It doesn't leave code hanging around in the notebook. And so how are we going to do it? We're just going to have some content. We're going to mark it up with cell tags. This is a very easy sort of thing to do. I'll show you how. And then we just work magic with the very nice introduced in version 9 cells function. So, by the way, nothing I've shown here yet is specific to version 10. So let's see how that works. Okay, so here's our new content. And I happen to have turned on, in the cell tags menu, I happen to turn on the show cell tags just so you can see this. So I have some cells here which I've tagged with the gray code tag. Once again, that's something you could have done under the cell tags menu, add remove. And then for generated stuff, I just made my own cell expressions. The only reason was so that I wouldn't have to actually add the cell tag by hand. So, I think I know why that is. I guess we're going to be a problem today, aren't we? Okay. There we go. Okay, so there's one output cell, and here is the other, and these have been appropriately tagged, and they're sitting here in my notebook, in the notebook with the generation code, and that's okay. I'm just going to go on to the next slide where I can show you what we're going to do with it. It's very simple. I'm just going to create a document, and the document is going to be all the cells in this notebook which have that cell tag, and that's it. So I said we were going to programmatically generate a notebook that sounded scary, but it turns out it's not scary at all. And it's actually only one line of code. I just split it up into 4 for ease of reading. So let's run it, see what happens. And here we go. Here's our interactive document. Everything works just fine, and now it is totally stripped of code. But we can regenerate it anytime we want to. We have a source notebook, we have a destination notebook. Very easy to regenerate. Okay. Now there's a third option. The third option is that we could use the new notebook templating features. That's not in this talk. That's tomorrow morning. I'll be talking about that again tomorrow morning, but there's the notebook templating features are new to version 10, I'll just say, and there's some really exciting stuff going on there. Okay, so now that we have it, let's make it available. And I just realized that I closed that notebook, so let me rerun the deployment again. Here we go. Okay. Okay, so how do we actually send it out to the world? In the vein of doing programmatic stuff, well, it's easy just to extend that and write one more line of code. And here's what I've done. I can make it available to anyone with Mathematica or Player or any of the other Wolfram System products. CDF deploy, and it's as simple as that. And so that's one option. Another option is new to version 10. Now we can make it available on the cloud. And so we have a CDF deploy, we have a cloud deploy. And so what I'm doing here is I'm just using the second argument of cloud deploy so that it repeatedly deploys to the same cloud object over and over again. If you don't specify the argument, then you'll create new ones every time, and you'll have a bunch of historical garbage in your cloud space that you won't be able to figure out what is what. And so let's go take a look at that. And that's not my web. Is that my web browser? Yes, that is my web browser. See, that's how good the system is. I can't even tell whether I'm in Mathematica or not. Okay, so that's so that is what deployment looks like. Now, I talked about interactions. There are some more advanced interactions that you can do as well. And this is the part of the talk that's going to be new for version 10, or maybe even a little bit beyond. This slide, though, is stuff that you'll see in version 10. Now, unfortunately, we have this very nice functionality called interpreter, which is the backbone behind a lot of the stuff that you'll see in terms of control equals or form functions or something like that. Unfortunately, we didn't quite get a chance for version 10 to plug interpreter into manipulate, which I think is a terrible shame, and I'm going to go back to the States and fix that. But I did write something. This is all stuff that's in the version 10 documentation, so it wasn't kind of too difficult to figure out for someone who basically, you know, understands the dynamic system. And basically what I've done here is I've created an input field that, uses interpreters. So my manipulate here is, it has two input fields. One understands its contents as a location, and the other understands its contents as a quantity. And then it's going to do some nice geographic stuff with them, assuming that my network doesn't fail outright. So let's, let's see. Okay. Come on. Okay, sorry about that. Sometimes I do that by accident. And there we go. Nope, that was the wrong one. Okay. Okay, let's try that again. Okay, one more time. And now if we want to take a look at Frankfurt and a distance of, say, 20 kilometers. And now we can get ourselves, if everything works, and there we go. We get ourselves a map 20 kilometers around Frankfurt. But it's not just, it's really kind of any place, anything that, this is going through like Wolfram Alpha type code, and it's really any place that Wolfram Alpha can understand as a place. So if I want to do, say, the Space Needle, and let's see what's in an 800 meter radius of the Space Needle. And we wait, and we wait, and we wait. Oh, too tight. Yes. Ah, there we go. There we go. Okay, I just wasn't patient enough. So, the system understands Space Needle is an object that is located in a certain place in Seattle, and it figures that out. Okay. So we can get live data from the cloud as well. And although actually I think this demo is not going to work since I had to close and reopen my notebook, which is a shame because it was sort of a nice demo. But yeah, I should have saved my notebook. Okay, we'll have to pass that one by. Sorry about that, folks. Okay, so an abrupt end, sorry about that, to the interactive stuff. Let me talk a little bit about, so I said I had two codas. I don't have too much time for them, but I'll fit in when I can. Okay, so I got the interest, or I got the idea that there were a few people here who were kind of interested in multiple undo as a feature. So I thought maybe I would say a little something about it. That's if you're all bored and this is passé, then go ahead and take off and get some coffee or something. But okay, so let me just talk a little bit about some of the things that you're going to see in version 10 with multiple undo, which are hopefully you'll just take for granted. Hopefully you won't think about them at all because it will just seem invisible. But so one of the things that we have to think about is out-of-sequence actions. Okay, so if we just do a simple evaluation, and this creates a bunch of individual cells here, and then it would make sense that undo should undo all of that in one stroke. It would be kind of annoying if you had to undo 10 times to get rid of this. But what if we did, what if this takes, I mean, that was instantaneous, but what if this, this takes a while? So I'm American, I'm bored now. I want to do something else. So let's create some content and are we finished yet? Come on, really, this is taking forever. Maybe we'll get rid of that. Okay, so now everything's done, but we had stuff coming in at the same time, and we already kind of established as a principle that we like Shift-Enter to be able to undo all in one stroke. How do we do that? Okay, so the, and you see here, it still treats everything that was coming out as, and I'm going to redo it here, everything that comes out as all one bit. But then it's also keeping track of my actions. Now, it's possible to tie yourself into a, into a real knot here where that's just not going to work. And if that happens, then the undo system is riddled with backstops. It knows when it's about to do something wrong, and it stops. And so if that eventuality is about to come to pass, then it clears the undo stack, does no harm. Okay? So undoing arbitrary kernel actions. Well, there are some things that, sometimes when I do stuff, it might not be as a result of typing or whatever. It might be as a result of a button press. But whose button? I just wrote this code myself. So I would like to, and this, just does arbitrary manipulations to the cells that we see below. And I would like to be able to undo that, but it's a button with user code. So, we have to be very good about being able to aggregate all those things together, treat them as one sort of action, and anything that might be done. And so that is another situation that you don't have to think about this when you're writing controls that change content. Okay, so recognizing whether inputs or outputs are synchronized. Oops, I meant to have a empty slide there. Okay, so that's and that's this feature which John referred to this morning, which is the output grain feature, where now if I start, and I wonder if that is an artifact of this style sheet. Oh, there we go. Yes. Okay. Yeah. Okay. So so there we go. If I undo my way back to $version, it shows black. So and this is this is really good for if I'm doing something like this, and I get my result, and then I decide, no, I want to change here, and then I get my result, and it can be difficult without cues like this to figure out, is this consistent? I have a plot3D command, now I have to look at the content, but no, I don't anymore, because the grain feature just works. Okay. And should controls be undoable? Hey, this is a slide I was working on when my time came up, so I don't quite have an example for this. But the answer to this is sometimes yes, sometimes no. And it turns out that in Mathematica we use we eat our own dog food. A lot of our controls are a lot of the things that you do in Mathematica are built from our controls. So the most of the time the answer is should controls be undoable is no. If I have a checkbox and I check it, undo doesn't undo the checkbox. If I have a slider and I move it, undo doesn't move the slider unless you ask it to. It's part of the language, documented in the dynamic module documentation. Okay, so, and let me get back to, no, I'm not going to be able to do that. Okay, so Coda 2, output syncing. So this is, and sorry, we're going to have to stay in the working environment here because I didn't check my slideshow environment that that it broke this feature. But so let's take a look again at this feature. So we know that if we make a change that it's going to gray. Now I can type the change back in and it returns. One of the nice things about this is I am often making fiddly little changes because I'm kind of compulsive about having my code formatted exactly correctly. Can I, maybe I want to, have new lines in certain places or something like that. All of that is perfectly well understood. I can even add a comment here, and as long as it parses the same way, it understands the output syncing just fine. So I think I've run out of time. So, I will just mention at the very end, I don't know if we have time for questions, but I'm going to be around all day today. Track me down. I'm not going to be around all day tomorrow. I'm leaving shortly before the experts panel. If you have questions for me, don't wait for the experts panel. Thank you.